problem solving with a system of linear equations. This video will help you solve a simple word problem that has two unknowns, solve a mixture problem with two unknowns, and solve investment problems with two unknowns. Solving a simple word problem with two unknowns. Let's go ahead and start with an example here that will kind of get us used to solving a very simple linear equation that has two unknowns. And I've given us kind of some bullets here to keep us on track. And so the first thing we want to do is identify the variables, and that's plural because we're going to have two unknowns. And you can take a look at our example here. Find two numbers whose sum is 40 and whose difference is 16. So here we know we're looking for two different things. So the first thing we want to do is identify each of these unknowns with a variable. So we'll say let's let x equal something, and we'll let y equal our other unknown. In this case, we have two numbers, and there's not a lot of distinction between these two numbers. So I'll just say that x is our first number, and then y will be our second number. Once we get our variables identified, now we want to write our two equations. And so we're going to have a system here. So we'll put a brace. And in this system, we're going to have two equations. So I'm going to put two equal signs. And I personally think it's easiest to kind of start with our answers or our totals in the problem. And you'll notice we have two of them. One is right here. You know, two numbers whose sum is 40 and their difference is 16. So these equations are kind of going to be written like this. And again, kind of starting with the end, or where we're going to end up, I think makes it a lot easier to write these equations. So now what we want to do here in this one is say, okay, what are we going to do to come up with this answer of 40? Let's take a look back in the problem, and it says two numbers whose sum is 40. That means if I add these two numbers together, they're going to have to come up with 40. So I would say, okay, let's take our first number, which was x, add our second number to it. That's going to give us this sum of 40. Now let's take a look at our next equation. Kind of coming up with an answer here of 16. Let's go back to the problem and see how we get that. Whose difference is 16. So that just simply means we're going to subtract these numbers and get an answer of 16. It really doesn't matter at this point which way I subtract them, so I'll just leave them just like this. X minus y equals 16. Okay, now I have my system of two equations. Now I want to solve. And we're going to use substitution to solve this. So I need to isolate one of my variables. All four of these variables would be easy. Maybe three of these variables would be easy to isolate. Any of these ones that are positive would be a good one to isolate. I'll isolate this one. So in this equation, to get x all by itself, I would add y to each side. So then I would have this. X is equal to 16 plus y. So I'm going to take this quantity now and substitute it into the other equation for x. So I'm going to come right up here and put it now into my other equation for x. Let's kind of come over here and take a look at what we have then. So then replacing x with 16 plus y. Make sure I put that in parentheses. I'm not going to need them here, but it's always a good habit to put that quantity in parentheses, equals 40. Now that I've substituted, I have just one variable, y, in the equation. Okay? So these parentheses aren't really doing anything, so I can go ahead and combine my like terms, my y terms there. So I would kind of have this, 16 plus 2y equals 40. Subtract 16. 2y then equals, let's see, 20, so 24. Divide by 2. And we see that y is 12. I've gotten one of my variables. Now let's go ahead and find my other variable. I'm going to put that right back in to the place I isolated for x. I isolated x to begin with there. So then let's see, I have x equals 16 plus 12, and we'll see then that x is 28. Okay, so there are my two numbers. So let's see, I've identified the variables, identified what x and y were. I wrote my two equations, and when I wrote those two equations, I kind of based them on the totals here, 40 and 16. Then I solved it. Now I want to make sure I answer my questions, you know, and I would say, okay, the first number it looks like is 28. So I'd say the first number is 28. The second number is 12. There's my answer, but let's double check this. Okay, we want to make sure that these numbers have a sum of 40 and a difference of 16. So a sum simply means I'm going to add. So here's my check. First check would be just to add these together. 12 plus 28. When I add those together, I will get 40, so that checks. And now I want to make sure their difference is 16. And sure enough, when I subtract 12 from 28, I get 16. So I've kind of met both conditions of this, so I'm pretty confident in this answer. Now it's time to practice solving an application problem with the systems of equations. Go ahead and pause your video player and answer this practice question. When you're done, hit play to see how you did. If you kind of need some help here, here's again, the bullets are will lead you through this process. All right, let's take a look. So the first thing we want to do is identify our unknowns. Find the two numbers. Here's the question. It says right in there, we're asked to find the two numbers. Again, these are unspecific things, so I'll just say, okay, how about x equals the first number? And we'll let y equal the second number. Okay, now I'm going to write a system of equations. So I know I need two equations, and again, let's start with the total. The sum of two numbers is 77. There's one of my answers or totals. One number is 7 more than the other. That's not going to work for finding the totals. We'll have to kind of take a little different strategy there. Let's start with this 77. We'll write that equation, then we'll take a look at that second equation. So the sum of two numbers is 77. All that means is if we add these two numbers together, we're going to get 77. Next part here, one number is 7 more than the other. So one of these numbers is going to be 7 more than the other. Let's say then if I took x plus 7, that would equal y. So that equation right there says that y is bigger than x. And that's okay because we don't know which variable or which number is bigger than the other. So this says that kind of y is 7 more than x. And that way if I was to add 7 to x, then we would end up with this statement of equality. So that makes sense. There's my second equation. Now that I have my two equations, I've kind of identified the variables, written the two equations. Now let's go ahead and solve this thing. Substitution would work great here. Y is already isolated. We can see that y is equal to this x plus 7. So all I'm going to do is replace y with that quantity x plus 7 in the equation above. So let's see, I'd have x plus 7 equals 77. Go ahead and combine my like terms there. X plus x will be 2x. Okay, minus 7. Kind of come over here. Let's see, then we have 2x is equal to 70. Divide by 2, divide by 2. All right, we've got one of our variables. We see that x is 35. Let's go ahead now and plug that back up into this equation right here. Plug that into this equation right there where y was isolated. So let's see if we come over here and take a look at that. We'd say then that x, which was 35, plus 7 equals y. So then we see that y was equal to 42. Okay, now let's go ahead and answer the question. We're looking for these two numbers. So we'd say first number, we said x was the first number, so the first number equals 35. Second number equals 42. All right, one last thing. We want to check and make sure it's kind of meeting these requirements. So let's see. They would have to add to 77. So if I took 35 plus 42, added those up, yep, I would get 77. And one number has to be 7 more than the other. Well, if I take 42 minus 35, you'll see that that number, the 42, is 7 greater than the other. So we've kind of met both requirements here in this problem, so we're confident in their answer. Now let's take a look at an example problem where we're working with a mixture of kind of two quantities here. And so we're going to step it up just a little bit here, but it's still, if we follow that same process, we'll be able to solve this problem pretty simply. Okay, so example 2, a 100-pound mixture of two different grades of coffee costs $277.50. If grade A costs $3 per pound and grade B costs $2.50 per pound, how many pounds of each grade were used? Okay, so notice right at the end here tells us what our variables need to be. And you can always usually look for the question in the problem, and that's usually going to ask you or identify your unknowns for you. So what we're looking for here is the pounds of each of these grades of coffee. So we'll say X is going to be the pounds of grade A coffee. Two different grades. Yep, grade A. So grade A coffee. And then we'll let Y be the pounds of grade B. We wouldn't want to simply let X be grade A and Y be grade B because it will be hard for us to write our equations. We need to make sure that we specify that this is actually the pounds of each of these coffees. Okay? Now we're ready. We've identified our variables. Now we're ready to write our equation. So I'm going to write my system of equations here. And again, I think it's going to be easiest if we always try to write these totals that we're coming up with here. And there are two totals. And each of those totals is going to give us our equation. Here's the first total. We have 100 pounds of coffee. So one of these equations is going to have to be 100. The other total that we have here is that this coffee altogether costs $277.50. Now that I've written down my two totals, let's go back to the problem and figure out how to write these equations. So this first equation has to do with the pounds of coffee that we have. Well, notice we have two different grades of coffee, grade A and grade B, and we know altogether we have 100 pounds. Well, we've already identified our variables. X is the pounds of grade A, Y is the grades of pounds of grade B. So if I just add the pounds of each of these together, X plus Y, that would give us a total of 100 pounds. And that makes sense. We're adding the pounds of grade A plus the pounds of grade B. Altogether, we're going to have to come up with 100 pounds. This next equation now has to do with money, how much money we're getting, or how much money we're spending, to get this coffee. You know, we have spent this $277.50. Well, how do we come up with a total amount of money? You know, if we're looking at just grade B costs $2.50 per pound. That means every pound of that I buy, it costs me $2.50. Now, if we look at grade A, that costs $3 per pound. So every pound of grade A that I buy, I get charged $3. There is how we're going to come up with this total of $277.50. If I take the pounds of grade A, which I know is right here, that's X. If I take the pounds of grade A and multiply it by $3, that would tell me how much it costs for this amount of grade A coffee. So in my equation, I would write this, 3X. That says $3 times every pound of grade A coffee that I buy. Now I want to add to that the grade B coffee that I'm buying. There it's $2.50 per pound, so I would say 2.5 times Y. And that would tell me how much I'm going to get charged for this grade B coffee. When I add the two together, I get this total of $277.50. Okay, now I have my equation. Now I'm ready to solve this equation. I'm going to use substitution, so let's isolate one of these variables up top here. Let's isolate X. If I isolated X, here's what it would look like. I would have X equals 100 minus Y. All I did was subtract Y from each side of there. So there is the quantity that X is equal to. Now I'm going to substitute that in for X in the next problem. So I'm putting this 100 minus Y right in there for X. So I'd have this 3 times 100 minus Y plus 2.5Y equals this 277, and I'll just write it as 0.5 now since we're getting ready to solve. Okay, distribute the 3. So I'd have 300 minus 3Y plus 2.5Y equals 277.5. Okay, combine our like terms here. Negative 3Y, positive 0.25. Kind of come up here to finish. When I combine those together, I'd have this 300 minus 0.5Y equals 277.5. Okay, subtract 300. See, then I have negative 0.5Y equals 277.5 minus 300. When I do that subtraction, I get negative 22.5. And let's not get alarmed by these negative values right now, because notice the next step is going to be divide by a negative value. And when I divide by this negative value, it's going to make it positive. So let's see. Divided by 0.5 equals 45. Okay, I found y. Now let's go ahead and find x, which means we're going right back up here with x. Okay, I'm running out of room, so I'm going to slide over here to the left. So I'm taking this equation right here, and we're plugging this value of y in there. So I would have this, x equals 100 minus 45. And so then we'd say, okay, x equals 100 minus 45. That would give us 55 for x. So it looks like grade A, I have 55 pounds, and grade B, I have 45 pounds. So let's see. X was 50, so 55 pounds of grade A and 45 pounds of grade B. So I know that these things are going to add to 100. The only other thing I would need to check is plug it back into this equation. Here's my answer. The only other thing that I would need to check is plug it back into this equation here, multiply it out, and make sure that I come up with this total price of $277. Now it's time to practice your understanding of working a mixture problem, solving this with a system of linear inequations. Go ahead and pause your video player now and work this problem, and hit play when you're done. I'm going to encourage you here to go ahead and try. You may not actually be successful on this attempt, but there's a lot of information to take in here, and the way that we learn is by trying. So go ahead and give this a shot. See how you do. Okay, let's take a look. First thing we're going to do is identify our variables. So we'll say, okay, we're going to have to let x equal something. We're going to have to let y equal something. These are going to be the unknown things in our problem. And if you always look towards the end of the problem, usually that's where it'll tell you what we're trying to look for. Find the calorie content of each candy bar. So we have calories, and let's look at our candy bars now. One of them was a Snickers. Calories in a Snickers, and then calories in the peanut butter cup. Okay. So now I've identified my two variables. Now let's go ahead and write our two equations. So let's see. Try to set our system up over here, leave us a little more room this time. Let's look for our two totals. One of our totals was this 737, and the other total was this 778. So let's see, 737, 778. All right, let's look at how we came up with this total right there. One Snickers bar and two Reese's peanut butter cups contain 737 calories. Well, one Snickers bar, the calories in one Snickers bar is right here. That's just what x is equal to. So there's one Snickers bar. That'd be the calories in that thing. And if I add to that now, two Reese's peanut butter cups. Well, here's the calories in one Reese's peanut butter cups. That's y. So to get two of these, all I'd have to do is take 2y. All right, there's my first equation. Now let's look at my second equation. Two Snickers bars and one Reese's cup. So I would say now 2x, two Snickers bars, calories in that, plus one Reese's peanut butter cup, gives us this 778. There's our two equations. Now we're ready to go ahead and solve this system of equations. So let's see, isolate one of these variables. Both x and y are isolated. I'll say, let's use x right here. We'll isolate x there. That would mean I just subtract 2y from each side. So here's what that would look like. I would have x equals 737 minus 2y when I isolated x in that. So now I'm going to take this quantity, substitute it into the next equation down here for x. So then it would look like this. 2 times 737 minus 2y plus y equals this 778. All right, I distribute the 2. So when I distribute the 2, I get 1474, and then minus 4y plus y equals 778. Okay, combine our like terms here, the y terms. So then I'd have 1474 minus 3y equals 778. Okay, now I'd subtract 1474 from each side. Okay, let's kind of come right up here to finish this. So on the left side, I'd have negative 3y. On the right side, when I do that subtraction, I get negative 696. Divide both sides by negative 3. And I get positive then 232. And so I found y. Y was the calories in a Reese's peanut butter cup. Now I just need to find x. So let's take this y value and we'll bring it right up here. Plug it into where we isolated x. Right there, we'll plug that in for y. So then let's see. So x is going to equal then 737 minus 2 times the value of y, which was 232. So let's see. 2 times 232 is 464. And then subtract that from 737. And we get 273 for x. All right, we found our both variables. Now let's answer the question. So it looks like x, that there are 273 calories in a Snickers and 232 calories in a Reese's peanut butter cup. Okay, there's my solution. So there's my solution. So now what I would need to do is I would need to double check, plug them back into both of these equations and make sure they make both of these equations true. If they do, then I would be confident in my answer. Now let's go ahead and practice solving an investment problem that has two unknowns. Go ahead and pause your video player and work this practice question. When you're done, you can hit play to see how you did. Okay, let's take a look. First, we'll identify our variables. So we have an investment now, and it's getting invested in two accounts. One earns 4% simple interest, the other earns 2%. So let's say we'll let x be the 4%, and so that's the amount of money invested. The amount at 4%, and then y would be the amount at 2%. Okay, we're ready to write our equations now. And again, let's start by looking at our totals here. One of our totals is that he's invested $5,000 in total. All right. The other one is that at the end of the year, he earned $144 on this investment. Okay, there are our two totals. Let's start out and now write our equation. How are we going to come up with this $5,000? Well, he kind of split this investment between this one at 4% and this one at 2%. So if I add these investments back together, or the amounts of money that was invested in each of these accounts, that's going to give us this $5,000. The next account has to do with earning interest. And so what we're going to do is we're going to take 4% times this amount that he's invested, and then 2% times this amount that he's invested to come up with this total of $144. So we would say 4%, but when I write 4%, I want to write that as a decimal number. So that would be 0.04 x, and then when I write the percent for y invested, it would be 0.02 times the amount he's invested in that account. There are our two equations. Now we're ready to solve. So I'd isolate one of these variables. Let's go ahead and isolate x there. So here's what that would look like. X is then going to equal 5,000 minus y. We're going to take that quantity now and substitute it into our other equation down here for x. So here's what that would look like. I have 0.04 times now 5,000 minus y plus 0.02y equals 144. Okay, got some decimals here, but that's not going to change the way I solve this. I would start by distributing the 0.04. So let's see. Okay, so when I take 4.04 times 5,000, I get 200. And then it's just going to be minus 0.04y plus 0.02y equals 144. Let's combine our like terms there. If I take a negative 0.04 and a negative 0.02, that's going to end up with a negative value there. So I have 200 minus 0.02y equals 144. Let's kind of come up over here to finish. So then what I want to do next is subtract this 200 from each side. But let's rewrite this first. Okay, so I would want to subtract 200 now from both sides. And so then I have this negative 0.02y equals, and I'm going to get a negative value here, negative 56. Now we divide both sides by negative 0.02. That we get 2800 for y. So now to find x, we'd come right up here and plug this value in for y. So it looks like, you know, x is going to equal this 5,000 minus 2,800. So when we do that, we get 2,200 for x. Now let's go ahead and answer the question. So it looks like the x amount was 2,200. So we want to put a dollar sign here. So we'd say 2,200 invested at, and the x amount was 4%. And then we would say 2,800 invested at 2%. So the check would be add them together and get 5,000. That would be an easy one. And then the second one we want to check is when we put these values back into this equation, make sure that we end up with $144 in the end. If those check out, then you can have confidence in your answer.